Hi, everyone. I'll start first by apologizing. I am not truly a geotechnical engineer, and I did ask the organizers if this was a safe space for non-geotechnical engineers, but I'm a civil engineer, so I think we're all friends still. Yeah, I did work with a lot of geotechs over the years, so I will clarify that. I'm talking a little bit about something different. So I know you've had a lot of topics, and I know this is called a technical session, but I am going to warn you that I am inherently going to speak about what is traditionally thought of as non-technical items. If that upsets you, that's why you have beer. If it doesn't upset you, that's also why you have beer. So we're in the right space for this conversation. It's a little bit different. I am a professional engineer by license, but a lot of what I do is on the periphery of what I was trained not so long ago as being engineering. And so that's what I'm speaking about a little bit today. So some of it might feel a little bit different than what you're expecting for a technical talk, but that's also very much the point of what I'm hoping to talk to you about today. It's about engineering with context and understanding the framing of why you and I engage in engineering on a day-to-day basis. The framing of why we do it, how we do it, what bias we might bring to that, and the context that we need to understand before we can actually apply a solution to a problem or what we think or perceive is the problem. So I know you did a land acknowledgement, but I like to just take a minute to acknowledge this land because I am not originally from here. Don't hate me, I'm from Ontario, sometimes referred to by Albertans as Onterrible. I've started using it in sentences, I'm working on it. I grew up outside of the GTA, also not a great sign, but I'm not a Toronto Maple Leafs fan, so I think that that's going to put me in the good books here, unless you're a Maple Leafs fan, in which case you'll probably just be angry because that's usually how Maple Leafs fans are on a day-to-day basis. I grew up in the territory of the Treaty of the Wampum Dish with One Spoon, Treaty, and that's traditional Erie, Huron-Wendat, and Haudenosaunee territory, so Southern Ontario. I am an uninvited guest to Treaty 7, so it's important for me to acknowledge the land because my mother literally is a settler. She came on a boat when she was 8 years old and settled in Canada. And it's the privilege that I have to be able to stand and present to you today is by virtue of being an uninvited guest settler within Treaty 7 lands. I also like to make abundantly clear, I am not Indigenous. I work a lot with Indigenous communities, specifically First Nations. But I want to make that very clear because sometimes there's assumptions made and I am not. I am white, settler, whatever you want to call me, I'll answer to it, even if it's not my name. I get Kelly and Karen a lot and I will answer to it. Karen's not my preference though for social media reasons, so Kelly would be preferred. But I'm not from here, so I like to make that acknowledgement. I do also work a lot with Treaty 7 nations, so I engage a lot with Blackfoot Confederacy, Siksika, if you haven't been to the east of the city, Piikani and Kainai to the south, but also the Confederacy traditionally comprises south of the border. So it traditionally comprises Blackfeet Nation in Montana, but it's only by virtue of our borders that we put in place that we only comprise those three within the land designation. But the Confederacy actually is a lot larger than that. I spend a lot of time in Tsuut'ina and also West Stoney Nakoda Nations, Chiniki Bearspaw, and what's now known as Goodstoney. Being able to work within this space is a privilege, so I want to acknowledge that. I also want to tell you kind of a little bit of who I am because that's the context of how I do engineering, and I think it's important. So I am a fish that swims in the wrong direction, is what someone has said to me. I loved engineering and hated it all at the same time. Which I think many people did in their undergraduate. I have some students, past and current, who are really feeling that sentiment right now. You love it, but you also hate it at the same time. I never found my home in engineering because I was trying to find a place where I could make the world a better place. And I never found it in my undergraduate experience until my very last year when I left the country and went to work overseas. And I worked in a very rural location in Southeast Asia. And I realized, oh, I think I understand now the connection between engineering and making the world a better place. And a very important mentor said to me, so I really wanted to be a doctor. I don't know why, but I wanted to be a doctor. And she said, what are you doing? As a doctor, you'll only solve the problems once they've already happened. As an engineer, you can stop the problems from happening in the first place. And it was a light bulb moment for me and one that I share regularly And I think it'll come out in the presentation today. So it's a little bit about me. I did work in consulting for quite some time, long enough to leave, but I know there's a lot of consultants in the room, so I value the work that you do. Wasn't my favorite place to work, but I also worked in land development. I worked with a lot of geotechs in commercial and residential development, and they were by far the most fun people in the office, without question. And every year we have in the class that we teach, which is environmental engineering, I try and weave indirectly and directly a bit of geotech into the conversation, recognizing that no matter where they work, they're going to either engage directly with geotechs or they're going to engage indirectly and need to have that understanding to make good decisions. I'm very happy to say that this year was by far the largest number of students who said to me directly that they are super excited to work in geotech. I don't know what happened. Maybe it's your events, but I had, 2 of them are here. I had over 10 students go out of their way to tell me, out of 120 students, that's still a lot, tell me how much they're excited to get a job in geotech. So if you're looking for students, I got some gems that are ready to work within this space. I'm very people and health focused, but mostly what I do is work with communities, and that's what's gonna come out today. I have done my very best to make this somewhat relevant to the world that you might be in and a little bit outside of the world that I'm in. I've tried to make those linkages. If some of them are wrong, you'll forgive me, but I'm also going to weave in quite a lot of water related because that's where I've spent the most amount of my time. So the first thing I'll start with is whether you believe that climate is changing or that there is a changing climate. I don't care how you put those 2 words together. Just that stuff's changing is our agreement that we make in our 3rd year environmental engineering class, is that the world is not what it once was, and it's going to continue to change. So how are you going to deal with that? And the biggest word that comes out in our conversations is resilience. I want to build resilient communities. I want to help people achieve a resilience so that it doesn't matter if things are changing, we can adapt. And what we do really good at is helping students and engineers understand the technical excellence required to build resilience. What we do a not so great job at is helping engineers and technicians understand the social and cultural and contextual understandings that are required to build that resilience. And I'm going to share a few examples as to why I feel that statement is still true. We're really trying to do that in a better way. You can see it in the way that we're accredited as engineers now, or in the technical space, how we're accredited and get licenses in a lot of spaces has changed. It's no longer just how great you can do calculations, but it's how you can actually understand the world around you. And I think geotech is a really interesting space where that's so true because it requires you to understand the real world in a lot of cases. But I want to give you an example, and the example is going to be in drinking water, so bear with me. And it's the curious case of drinking water treatment. So when I graduated from my undergraduate, I started working for a few consultants. Over that time of getting my master's and PhD, I worked for a few different organizations, some nonprofit, some for-profit, some public sector, a little bit of everything. And what dominated throughout that conversation was a desire to make the world a better place by making sure that everyday Canadians always had access to safe, clean drinking water, right? You and I can go home for the most part, turn our tap on and not have any issue accessing safe, clean drinking water. It might look and feel different depending on where you are in the city. For the most part, it's pretty consistent and we don't have a problem, right? For the last 20 years, the one issue that I've been engaged on is drinking water treatment in Indigenous communities, and specifically First Nations. First Nations living on reserve. So on reserve being the plots of land that 150 years ago we deemed as where we were going to place First Nations people. And through that whole time, there's one theme that was consistent. No matter where I worked, there was no shortage of technicians and engineers who would email on a regular basis or come up to me and say, I have the technology for you to fix the drinking water treatment problem in Indigenous communities. And that was by far the most frustrating sentence I could hear in that 20 years of working within drinking water. Because the reality is, given that you and I have not had difficulty accessing clean, safe drinking water, it's clearly not a technology problem. Yeah? And yet that is the number one way that it has been tackled over the last 20 years. So I don't have slides on this, and sorry, is this cutting out a bit, or is it just me? I'm not losing it? Okay, it's just my hearing, that's fine, that's less concerning. It's okay, I don't qualify for the top 40 under 40 anymore, so it makes sense that my hearing's going for a crap too. So over the last 20 years, the state of play for drinking water and sanitation, I should say, has not really changed that much across Canada for those living in rural and remote communities, and in particular First Nations. And a big part of that problem has been not understanding what the actual problem was. So as engineers, we're taught how to solve a problem. As engineers, we're not really told how to identify what the problem actually is in the first place. And so we're more than happy to go out and provide you with your 3 best options as to what you want to do to adapt to this problem. Your do nothing. This is the one I hope you choose. And this one is so cost prohibitive that you won't choose it. So I've gotten you to get to that middle one, which is what I wanted the whole time. Those are the 3 pieces that we offer people. We don't stop and say, was that actually the problem that I needed to solve? So I'm going to park that in your mind for a second and take you on a little journey of the difference between technology and design and context and implementation. And to do that, I'm going to go completely outside of engineering for a second. And I want you, through the conversation, to think about not just this, the next stage, how is context integrated into our everyday design? How is it integrated into your everyday? I'm going to start with a number. And 4th is our ranking in Canada on the Human Development Index. Depends on what you're looking at and what year. Oftentimes it'll vary. So 12th is what it was in 2016. We had a bad go over the next 4 years, and we went down a spot to 13th. Generally speaking, you can count that Canada is in the top 10 on the Human Development Index. And a big part of what puts us on the Human Development Index is the world that we live in, the world that us, as everyone in the room, is creating and building and making safe. That's a big part of it. These are averages though, right? So these are averages for everyday Canadians. Not everybody is necessarily going to be experiencing that number. These are another set of numbers, and these numbers are still in Canada. So everyday Canadians, 10th, 11th, 12th, 13th. These numbers are Indigenous peoples in Canada. And it's not to share a deficit lens, it's to tell you the reality of inequity that exists in the engineering worlds that we're designing and the infrastructure that we have access to and the way in which we engage in society. 52nd is the general across all Indigenous people. 42nd is those living in the urban center. That's the average at the top. Bottom, 78, is First Nations living on reserve. And a huge contributing factor to that is access to clean, safe drinking water and sanitation. And the fact that the majority of First Nations across Canada are on decentralized systems, individual wells and cisterns, not wells that are dug well or chosen in appropriate locations, and not usually maintained, nor are they provided any resources to do so. It's considered a housing problem and not a water problem. And that's how it's funded. The majority of First Nations that I work with, so if you look broadly across Canada, you'll see at any given moment, typically the trend has been over 100 drinking water advisories, typically. Usually, there's at least 30 to 40 that are long-term drinking water advisories. Venture a guess as to what you think a long-term drinking water advisory is, and park it in your brain for a second and ask yourself, when the water main broke a year and a half ago, how long would you have lasted if that water main break wasn't repaired right away? What would have been long-term in your mind? The Government of Canada definition of long-term drinking water advisory for First Nations is anything over a year. So if you guessed a year, congratulations. You also probably don't really know what it takes to live even 24 hours without access to water, and I'm a little bit jealous. But for most of us in the city of Calgary context or municipal setting, if your water's off for 3 hours, someone's getting fired somewhere. That's the reality. Someone's getting a call and it's not going to go well. In reality, that over 1 year drinking water advisories, the majority of nations on that list are 10 years plus. So they've not had access to safe, clean drinking water in 10 plus years. 3 of the communities I work with, it's a quarter of a century. So it's 25 years. A lot of people I work with have never been able to bathe their children, have never been able to feel comfortable having a shower. And some of them that have gotten great innovations in engineering, like drinking water treatment, which is considered as one of the most instrumental engineering innovations of our time, is the advent of water treatment. The use of chlorination, it came from a time period in the UK when there was an outbreak of waterborne disease, and the inclusion of chlorine was considered this big deal. It's an engineering feat. And yet, here in a Canadian context, we still can't make that provision across Canada to the entire population. And that context is really important because that number for our context has not changed. So when I started working, I won't tell you the year, but we'll go back a couple decades, the number of short and long-term drinking water advisories is over 100. Where we're at right now is not that much different. In fact, a lot of the communities that were on long-term advisories when I started working are either still on a long-term advisory or have gone back on. So progress has been stalled. And yet the rest of us don't seem to be having that problem, right? Accessing safe, clean drinking water. And I ask you to think about it because one of the contexts that comes clear in these conversations is equity and access. Does everybody access your engineering interventions and engineering design in the same way? Does everybody have access to that in an equitable fashion? And what are you doing within your day-to-day practice, whatever it is that you do, engineering or not, geotech or not? How are you ensuring that that's shared across different places and spaces? And the reality is you might be thinking of it, but how you actually intervene within that case is a lot more challenging. It's more challenging and it takes more time. It takes more time, so it takes more money. And anybody who's written an RFP or is working on a job right now or project managing will know time is not something that you have. And so to be able to do this work effectively, you need both of those things. And it's the two things that you usually don't have: excess amounts of money and excess amounts of time. So we've defaulted to a status quo of if I just keep building something, it'll fix the problem. If I just keep doing the engineering, it'll help. It's a field of dreams. Those that are younger may not know the field of dreams reference, but if I build it, it'll all be solved. And it doesn't apply in real life. And we're not necessarily equipping people to understand that the design that we're doing, the interventions that we're doing have to address these two issues because the way you and I access some of these pieces is not the same as others. I share that problem because a fundamental piece of what it is that I do is actually unpacking, is engineering in my case the solution that's needed? And that might seem like a very bad business model, right? I'm going to approach you with an engineering solution and then tell you actually, no, you don't need an engineering solution, so I'm gonna write myself out of this job. What I want to try and tackle is that the innovation on the technological side may not be the solution, but the innovation on the process is where the actual innovation is and where the solutions can really be powerful. And the drinking water treatment one, although maybe not exactly in your frame of reference or what you do on a day-to-day basis, for me is a helpful reminder because it reminds me on a regular basis that we don't all experience this world in the same way. And that's why context is so critical. A big part of that as engineers or as technicians or as scientists is an inability or a lack of desire to see the forest for the trees. So if I'm working in a certain consultant shop and this is my job, I tend not to want to work outside of that. I'm going to do this thing that I've been asked to do and I'm going to pass it off to the next person. If I'm project managing, I'm going to try and make sure everything fits together, but I may not necessarily have an opportunity to step back and go, okay, wait a minute. What is in the client's best interest? Also, did I stop and ask myself, is what the client identified as a problem truly a problem? So we trust that our clients, when they come to us with a problem, understand what the problem is or think that they know what the problem is, and we don't like to reframe the problem. A fundamental concept in social innovation is to take that problem and throw it away and then sit at a table and now talk about the problem from a multitude of different perspectives and see if you come up with the same problem. And if you don't, fantastic. Now you're going to solve it in a new and exciting way. Again, time and resources, but what the study and the process shows us that if we do that early, we engage early, we can save time and save money in the end. So what we're seeing is upfront costs and upfront time, but in the long run, more sustainable projects more sustainable outcomes. I'm going to share a few examples, but I want to just unpack a few of the notions that are embedded in the world that we live in. And some of these are changing, but typically engineering or science or technology tends to feel itself as an all-knowing space. And we look to other spaces or other silos of professional practice as not being as all-knowing as we are. We know the best of what we need to do, and we sometimes will call on those individuals to help us, but we're the ones with the expertise. You can replace engineering with just about anything in that sentence, right? In our professional world, we tend to operate that way. The other piece is we tend to do so in isolation, right? On a major project, you tend to work on your space that you've been allocated because that's what you've been paid to do, and it's very difficult to find the time and the resources to work outside of that. One of the pieces that's embedded in that is a notion of stationarity, a notion of steady state, a notion that this is the world that we live in and that's not going to change. And if it does change, I'm going to make an assumption on an incremental level of change, but we're no longer in that world. Not even close. You can see it daily on the news that we're no longer living the realities of how all of those technical guidelines, standards, and regulations that drove my undergraduate, you can throw them all in the garbage now because none of them are predicting the world that we live in now. And of course, those are changing and evolving at the national and international level, but it's still a very challenging space to work in. No one in this room, I think, would say that their job in this current environment that we're in is easy. And that's where there's an opportunity to learn from different knowledge systems. And that's kind of where I want to go for the second part of this conversation, is that Indigenous knowledge systems and Indigenous science, and I say this as a non-Indigenous person, are the fundamental science that should be dictating how we approach life. And we've often thought that engineering is an advent of the post-revolutionary industrial revolution time period where we understood the world better and ergo we could design better. When in reality, for tens of thousands of years, Indigenous peoples across the world have been engaging in engineering. It just wasn't called engineering. They've been engaging in sustainable practices. It just wasn't called sustainability. Engineering and sustainability are two words that we used to define something that we're doing that was already being done. So we don't have to look far to find the support and guidance and knowledge that we need to be able to move forward. It should be complementary right now. It's not quite there yet. I'll give you an example. Anybody from the Lower Mainland? Well, if you were, you might recall this picture, or if you relied on any truck delivery from the West Coast during this wonderful time a few years back. This is the main Trans-Canada Highway that connects Vancouver through Abbotsford and Chilliwack in over the Rockies to us. So things get there from this main central road. And this is what happens when an engineering intervention fails. Yeah? Most people looked at it and were like, oh, just bad design, or like it wasn't maintained properly. O&M, who's giving money for O&M these days? Things are bound to fail. That bridge is gonna go for a crapper. It's cracking like crazy. No one's putting money into it. And so that's just a direct result of not putting enough money into the system. You might look at that and go, that was the problem. Maybe bad design, but more than likely it was a decent design that just wasn't designed to last as long. Or we just had one of those really bad storms, you know, those ones that are supposed to be 1 in 200 that are now what? Half that? So you look at that and think, okay, that was the problem. I'll just rebuild the dike system that was utilized in exactly the same way, maybe make it a bit stronger, make sure it lasts a bit longer. But then you'd be missing probably 90% of the context. And so if you are from the Lower Mainland, I also want to show you this picture. Same place. Pre-development of both the towns of Abbotsford and Chilliwack. People came in and said, this land looks pretty fertile. It would be great for farming. And if you've driven through the Lower Mainland, you will note really great farming, very fertile land. Some of your berries might come from there. There's some fantastic farms in Langley, BC, in Abbotsford, just outside of Chilliwack. You can get a great garden down there, maybe a little bit better than your Calgary backyard garden. This is Sumas Lake. Pretty important context for what happened when the dike broke in the Lower Mainland. And that's because while the dike broke, the water just went back to where it always wanted to be for tens of thousands of years, which is Sumas Lake. And for tens of thousands of years, indigenous peoples lived in and around Sumas Lake. At no point did it cross their mind to potentially move the lake in order to make their lives better. And in fact, if you dig through the BC archives, if you like to go through the archives, you will find quotes from that time period that say, a direct quote was, "I never would have thought to do something like that." We never would have thought to move nature in order for it to make sense for us, essentially. So Sumas Lake in the middle there, you can see, well, you probably can't because it's small, Abbotsford over here, Chilliwack up there. This is the home of the Solo people, beautiful territory, really not meant to be displaced in the way that we did it, right? So you could say it was bad engineering this last time, or you could say it was just a really not great idea back then, and a very fundamentally different thought process. But then you'd have to unpack the true root of engineering, which comes from 2,000 plus years ago with the Romans, who said, you know what we can do? We can control nature. We can harness the power of nature and make it do for us what we want it to do. One of the best design pieces that people look to when it comes to drinking water, not to go back to it, are the Roman aqueducts. Designed to transport water from wherever the heck the Romans wanted it, thousands of kilometers, not in a pipe underground like we do it now, but above the ground, to the Romans so they could control it. They didn't care what they went through in that process. They tore everything down in the way. It was a way of ensuring world domination. It's the same way that they built the largest network of roads in history, was through the development of those roads, was to have control and access to any of the areas that they wanted to have control and access to. And the same design principles that applied back then are rooted in our engineering practice now. It's not something that people necessarily want to admit, that we're all wearing our Roman colonizers hats right now, but my mother did come on a boat from Italy, so I feel confident in saying that some element of me is wearing a Roman colonizer hat. So I'm comfortable saying it. If you're not, that's totally okay. This is a safe space. But that was the intention behind the design then, and still is the intention now. The intention now is to control nature so that we can get what we need out of the land, so that we can get what we need out of everyday life. And at the bottom here, you'll see a picture. This is, I think, about, well, it's 2025, so about 100 years ago, of people engaging with boats on the Sumas Lake. And for me, it's a really powerful reminder of, did you take a minute to understand the full context of the conversation? And none of this really came up in the media conversations or the post-engineering or technical analysis of what happened in Abbotsford and Chilliwack. Because if it did, we would have had to have a really difficult conversation about, are we living and working and are we building communities in places that we should? And we don't want to have that conversation because nobody wants to move out all those people from BC because they'll be pretty pissed. I'm going to give you another example, and this one's maybe hopefully a little bit closer to home, but it's the Chilkoot Gold Rush avalanche. And this is a quote directly from an engagement. There's some references at the bottom. This is from 20 years ago, but on the Easter weekend of 1898, during the height of the Klondike Gold Rush, an avalanche swept down the Alaskan side of the Chilkoot Gold Rush Trail, killing 69 stampeders. Shortly before that happened, there was Indigenous, and you'll note the use of Aboriginal is just a context of the word that was used at the time of the publication and not one that I'm using. Indigenous people at the time said, you really shouldn't go over there. Our stories, they actually had songs that told them about the safety of the trails and the pathways. Our stories, our songs, and our knowledge tells us you shouldn't go on this route over the next few days. They chose to go anyway. 69 of them killed, not one Indigenous trailblazer was killed in that avalanche because they chose not to go. They listened to their traditional ways and knowledge, and those doing. Now, this is different motivations, right? Very different motivations to get on the Gold Rush Trail ahead of others. So I'm not saying that that's the current reality, but we do have a tendency to not want to listen to knowledge that comes from a different place. So if you read it in a book, or if I tell you that I have a story about it, which one do you feel the most comfortable in relying? If my calculator tells you one thing, but someone you're working with tells you something different, how comfortable are you in relying in a conversation versus what your calculator or your own calculations are telling you? So this is an old example, but I think an important one. The other example that I want to share is the case of soil analysis, which, again, a lot of people consider the advent of engineering as the way in which we started to understand the world, right? And we were able to document it and put it down on paper. When in reality, most Indigenous communities across the world for centuries have had their own ways of classifying soil in their traditional ways and understanding of the world. Ethnopedology is one way of defining that. It's the documentation and understanding of local approaches to soil perception, classification, use, and management. And I've given you some examples here, but in some communities, there's actually extremely complex soil classification systems that are not being utilized by geotechnical individuals, others engaged in these spaces, because they're not given the same weight as the weight of what we've learned in our engineering practice. So there's some examples here of Peru and in Nigeria, where they've developed different hierarchies for understanding the soil suitability for growing, the soil suitability for building or constructing, and obviously not constructing in the same ways that we're constructing now, but still constructing and living on. And then in other spaces where they've actually used symbols and different forms of language to define. So in some communities across the world, you'll hear within the definition of the word for the place will actually tell you something about the soil conditions, because that's often how they utilize language for place naming. So a great example would be, so Lake Louise, I'll give you an example. This one's not related to soil, but this is related to the lake. Lake Louise in Stony language is the lake of many little fishes, and traditionally had a lot of a certain kind of fish breed. Now, they've been doing research on historically what fishes were in Lake Louise for a very, very long time. And yet, there's a lot of Indigenous knowledge that can tell you about what previously existed there without having to necessarily open any of your scientific books or head into the lab, maybe save you a couple $1,000s on your grant applications if you're in research. If you're not in research, then you'll know that you get your money from somewhere else, but you might be able to utilize that money in new and exciting ways by actually engaging with people who have a history of understanding of the worlds that we're all living in, because our collective experience living on the land as non-Indigenous people is very, very short in the time frame that Indigenous people across the world have that experience and stories carried down. One of the biggest pieces that's embedded there is an understanding that the land is a living being. Not a concept. I'm not sure how many of you learned that the land is a living being in your undergraduate careers. I'm sure, like in my undergraduate, it was frowned upon to talk about feelings. So I don't know if you were allowed to talk about them, but we sure as crap weren't allowed to talk about that sort of stuff. That was what you left engineering for to do. But really fundamental to a lot of this practice is the notion that land is a living agency. It has its own agency. It can make decisions on its own. That fundamental thought, even that sentence, is going to make some people in the room very uncomfortable. The fact that if I said to you, water has its own agency, it can choose what it wants to do and what it does not want to do, is going to make the technical left side of your brain go, what is she talking about? She's clearly had too much of that beer that she has on the table. Maybe, or maybe you're like, this could be really cool, but it depends where you're at in your own understanding. One of the pieces that's been really helpful, and in the space of geotech as well as water, is participatory mapping. So the ability to sit around a room and listen to stories and connect those stories to understandings of technical concepts. So I can sit around a room and I can pull up an image, and I'm going to give you an example here. This is a community in Saskatchewan. It's a First Nation community, and they are looking at understanding better the impacts of climate change on their water systems. So their whole watershed essentially is a very heavily agricultural intensive area. They're sort of right dead smack in the middle. They also happen to be not too far from some other great engineering feats like hydroelectric dams. And so they've seen major changes in the water that they have in their water bodies. And they want to better understand, and to do that, we engaged in the participatory mapping exercise over 2.5 years, where people were brought together in a space and asked to share stories. It didn't matter what the stories were about. We just shared stories by putting up a map and then asking them what they remember about that. So you have stories about how children used to be able to walk through one of the river areas because it was that shallow all times of year that their children could walk through. Right away, that's probably 6 to 10 data points that science doesn't have, because this is also happens to be the space where there's absolutely no data. So context again, most of the time when you're working in rural and remote communities, you have zero data to work with because no one's been there before, no one's cared to do the data before. Most of our data dominates in the southern part of the Canada, where there's larger municipalities. So we have a huge data need, and a huge ask to try and go out and figure out what the information is. What are the soils that are there? What are the conditions that I'm looking at? We don't have it. And so instead of trying to get out our gauges and measure and try and use models to understand what used to happen, we just have to engage in a conversation to be able to document. In the end, across maps that span the entire room, adding over, at the time, 300 different post-its of different stories, and then mapping that to an ongoing model they were developing to determine how that community might be impacted by actually understanding what happened before. Again, it's something that takes time, it's something that takes money, and it's something that not everybody in the room is going to feel comfortable doing, but the richness of the data that's embedded in those conversations is massive. You will never be able to match the richness of that data in the same ways that Western science is only now starting to unpack. Another case, and you may be more familiar with these in the Andes and the Pacific Islands, is the use of slow-forming terraces. This is something maybe more in your comfort space that's been around for a while. And it's the use of gradually building these slope gradients that are used to improve the soil quality. They've been done for thousands of years, something that only now science is beginning to understand why communities have engaged in these practices and are learning from them a bit too late, probably. And the last one that I just want to point to is a more recent one, which was looking at Alaskans and Indigenous people living in Alaska and their understandings of the world that they live in. And so scientists have been doing tons of research in the North, right, for a very long time. Some of you might have engaged in research within that space or worked within that space. And what they did was take a minute and talk to community members. And what you realize really quickly is that what community members are saying actually, and corroborates isn't the word that I want to use because it's a notion that Indigenous knowledge or local place-based knowledge has to validate science, when in fact we're trying to reverse that and say that our science is now corroborating or supporting what has been known the entire time. We just didn't ask the right questions. And so it's starting to weave together different data sets that don't just have numbers on the page, but have stories. And that can be an uncomfortable practice for people who are used to having data sets and Excel sheets, to add in narrative and story. But the richness of that data is so powerful. I promise you, if you jump into a few of these cases, you'll be surprised. So in the last few slides, I just sort of want to summarize a few things. So how do we engineer better, moving away from technologies and monoculture, looking at Indigenous ways of knowing and doing, trying to better understand how we can be more inclusive in our approach. How can we be inclusive of different ways of knowing and doing? And that's about getting outside of your day-to-day siloed approach and looking at what might be a better way of doing what it is that we've always done. Are there different ways of engineering? Are there non-engineering interventions that I can take that are still part of our engineering or technical practice that I haven't thought of because I've just been forced or told that there's only one way to solve some of these problems? When we engineer through community, and sometimes this is a bit surprising, but we often tend to save money and save time. And that can be counter to the part that I said at the beginning, that it costs more time and costs more money at the outset. But when we do that, we're sensitive to what's happening at a local level. We're not assuming that every context is the same. We're not taking the proposal or the RFP from somewhere in Manitoba and applying it to a project that we have in Alberta. We're actually taking a minute to understand the surrounding context of where we're working. It allows you to engage with individuals and have conversations more so than just the one-off presentation that we might have where we're pitching something in a public survey and saying, hey, we think you'll really like this project, and then we leave. When we do that, we can also increase the sustainability long-term. So projects that engage early have more uptake. Projects that engage early have longer buy-in from the community and longer-term sustainability. They're the projects that are lasting for decades as opposed to the projects that are lasting for a few years, or the projects that never get off the ground, which does happen in a lot of small, rural, and remote communities. is that engineers or others will come in, make a design suggestion, maybe get funding to do so, start it, leave, and when you go back a few years later, it's no longer in the condition that you thought it should be, nor is it even potentially even being used. It may not even have gotten to the end part of that project. Part of doing this work, and the part that can be a little bit uncomfortable, is having to recover from decades of bad engineering and bad practice. And unfortunately, that exists in a lot of communities that I work with. So decades of harm done by individuals who either thought they could do better, or were trying to take advantage of a system. And that exists, and not acknowledging that within this space or outside of this space is problematic. It does exist. It doesn't mean anybody in this room is engaged in it, but it does exist in the world that we live in, that individuals have gone after access to funds because they see an opportunity to work with, say, an Indigenous community, they see a grant opportunity, they engage in it, and then we have a situation where we have a project that hasn't been done well or hasn't been completed, and the nation or the partner is left with nothing because they were taken advantage of. And it's not something that I think people are comfortable talking about, but if you're not comfortable talking about it, then you're not really that comfortable having a conversation about how our practice sometimes actually works and how it used to work and how we're trying to get better, but we're not there yet. And this is part of the problem, is having some of those uncomfortable conversations. The one piece that I'll leave with you is sort of what I think is important, is to engage early, talk to people, and engage often, to respect Indigenous rights, data governance, and sovereignty, to think about co-creation of both problems and co-creation of solutions. So it's not just working together to find a solution, it's working together to identify the problem in the first place. And so maybe there's some questions you have for yourself as to how you might change this, or maybe you're not there yet, or maybe you're already doing it. Usually in these presentations, people in the room are somewhere along that spectrum. They've either never thought about it, they're already doing it, or they're somewhere in the middle, and they're not quite sure what to think of it. And that's all good, because you have beer at your table, and that helps to think. It does help with your thinking process. So moving forward, I would say this notion of building resilience is not just about your technical innovations, but it's also about relational, how you're building connections and partnerships and learning in new and different ways, how you're embracing in a different way of thinking. And partly, we're trying to shape that earlier on when we're bringing kids into school and teaching students to think a little bit different, a little bit outside the box. And also understanding that inherent in our conversations and inherent in how we work with people, and this is not just with Indigenous communities, but particularly when you're working with Indigenous people, is a notion of respect and reciprocity that doesn't always exist. We're working together because we both need to survive within this environment. We're working together because we both need to solve a problem. So I'll leave you with this, and it's not everyone's favorite engineering quote, but it's from the late Honorable Murray Sinclair, which is about innovation. And it's not always about creating new things, but involve looking back at our old ways and asking ourselves, can we bring them forward to a new situation? So I will end